All right, today we're going to tear into the engineering of what might just be the most advanced and most complicated jet ever built, the F-35B. This is a machine that's supposed to do the impossible. We're talking about being a top-tier fighter, a stealth bomber, and a helicopter all rolled into one. So how on earth did they pull it off?
You see, the whole idea behind the F-35B was to be the ultimate jack of all trades. But in the world of aerospace engineering, that is a huge, huge gamble. I mean, specialization is almost always the key to making something that works well. So trying to make one jet replace an entire fleet of highly specialized aircraft, that's a massive engineering headache.
And just look at the roles it has to fill. It's got to have the dogfighting agility of an F-16. It needs the radar-evading stealth of something like the F-117 Nighthawk, and it has to have the totally unique ability to land vertically, just like a Harrier jump jet. You know, combining just two of those would be a monumental achievement, but all three in one plane? That's just bordering on insane.
Okay, so let's kick things off with the first impossible task, invisibility. How in the world do you make a plane disappear from radar while also making sure it can still pull off the crazy high-G maneuvers of a top fighter jet?
Now, first things first, let's bust a myth. Stealth doesn't mean you're totally invisible, like a Klingon bird of prey. It's not a cloaking device. The real goal is much smarter. You want to delay detection. For a fighter pilot, that means you see the enemy long before they ever see you. It gives you this critical advantage, a first look, first shot kill, that can literally decide a fight before it even starts.
So to get stealth, you got to understand radar. It's pretty simple, actually. A dish sends out a pulse of energy, and then it listens for the echo. The absolute worst thing for stealth is something called a corner reflector. Just think of the corner of a room in your house. Any two surfaces that meet at a perfect 90-degree angle will bounce those radar waves straight back to where they came from, basically screaming, "Hey, I'm over here." So the goal is to get rid of those right angles and use angled surfaces to deflect the radar waves away, kind of like skipping a stone across a lake.
And you can see that exact solution in action right here. A normal jet's tail creates a perfect 90-degree radar trap. Now, a stealth bomber like the B-2 gets around this by just not having a tail at all, but that kills its agility. So the F-35 does something really clever. It's a compromise. It angles its twin tails, avoiding that 90-degree reflector, while still giving it the control surfaces it needs to be a nimble fighter.
But here's the thing about stealth. It's not just about the big, obvious shapes. It is an absolute obsession with the tiniest details. See those zigzag serrated edges on the panels? Every single access hatch is designed that way to scatter radar waves. Even the tape they use to seal the panels is specially engineered to absorb radar energy. The plane's skin itself is a composite material that literally soaks up radar signals instead of reflecting them. Every single surface is part of the solution.
And get this, even this little bump in front of the engine intake is a stealth masterpiece. It looks so simple, right? But it's an absolutely brilliant piece of aerodynamic design. It pushes away the slow, messy air from the engine, which helps performance. But just as important, it hides the super reflective fan blades of the engine from enemy radar. It's one simple-looking shape that solves a bunch of problems all at once, cutting down on weight, complexity, and the plane's radar signature.
Okay, so the F-35B can hide. Check. But its next trick? Well, it's arguably even crazier. We're talking about defying gravity. How do you make a supersonic jet just stop and land like a helicopter?
This transformation from a screaming fast jet into a hovering thing is just mind-blowing. The pilot pushes a button and bam, doors on top of the plane open up and a massive lift fan engages right behind the cockpit. At the exact same time, the rear engine nozzle, which is an incredible piece of engineering on its own, swivels 90 degrees to point straight at the ground. And to keep the whole thing from just tipping over, tiny jets on the wings shoot out air for balance, all controlled by a computer making thousands of corrections every second.
And to pull all that off, the single F-135 engine has to generate an absolutely colossal amount of power. We are talking 191 kilonewtons of thrust. To put that in perspective, that's more power than the two engines of an F-22 Raptor combined. And it's what allows this single-engine fighter to literally balance on two columns of air. It's just nuts.
But the F-35B's genius isn't just about the metal and the mechanics. It's also about its brain. The next great challenge its designers faced was how to manage the absolute fire hose of information that a modern pilot has to deal with.
And the secret sauce here is the helmet. See, in older jets, the pilot has a fixed heads-up display, or HUD, on the glass in front of them. So they're constantly looking up at the HUD, then down at their instruments, then back up.
The F-35 just throws that whole idea out the window. All that critical data, your speed, your altitude, your targets, is projected directly onto the pilot's visor. So the information moves with their head. No matter where they look, the data is always right there in their line of sight.
So how does it do this? Well, it's all thanks to a system of 6 infrared cameras mounted all around the aircraft, looking out through sapphire windows. These cameras feed into a central computer that stitches together a complete 360-degree view of the world. The system is so advanced that if the pilot looks down at their own feet, they don't see the floor of the cockpit, they literally see the ground right beneath them as if the plane itself were transparent. It's basically X-ray vision.
And its defenses are just as ridiculously smart. To beat a radar-guided missile, it can deploy a tow decoy on a fiber optic line. But this little thing doesn't just trick the missile, it actively fights back. First, bam, it tries to jam the missile's radar before it can lock on. If that doesn't work, okay, plan B. It tries to break the missile's lock. And if all else fails, its last resort is to perfectly mimic the F-35's radar signature, convincing the missile to come after it instead of the plane.
But you know, the real game changer, the thing that truly sets the F-35 apart, isn't what one plane can do. It's what a group of them can do together. They're all connected by this secure, high-speed data link, sharing everything they see in real time. This means one pilot could launch a missile at an enemy that only their wingman can see. It turns a squadron of jets into a single networked hive mind, where every pilot sees the entire battlefield at once.
But, and there's always a but in engineering, right? There's no such thing as a free lunch. To achieve all of this incredible genius, some very real, very painful compromises had to be made.
So, what is the price for all this genius? Well, let's break it down. That amazing vertical landing system, it adds over a ton of dead weight that the jet has to just lug around during normal flight, making it less nimble. That ridiculously powerful engine you need for hovering, it's actually less efficient at super high speeds, so it limits the F-35's top speed compared to other fighters. And finally, all those specific shapes and angles you need for stealth, they physically stop the plane from making some of the extreme, high-G turns that a dedicated dogfighter can pull off.
And all of this kind of brings us back to the central question of the F-35B, doesn't it? It's an undeniable marvel of engineering. I mean, it solves multiple impossible problems in a single airframe. But it's also a powerful reminder that in engineering, every single solution is a trade-off. It really makes you wonder, when you try to build the one machine that can do everything, what compromises are you willing to accept? What price is worth paying?